Welcome everyone. It's very exciting for us to welcome you to our first durability webinar in what will be a series of webinars that we're hoping to roll out next year, and obviously starting now. So look, I'll give you a quick intro to BCRC to start with. So look, for those who don't know, you probably all do know, but we're construction materials and durability consultants. And we like to think that's where thought leaders in this space when it comes to durability of buildings and infrastructure. We are led by our three well-known directors, Frank Papworth, Bob Munn and Marton Marosszeky, who are well supported by a growing team of highly capable engineers who are some of whom are starting to make a name for themselves in their own right in the industry. We have offices all around the country in Brisbane, Newcastle, Sydney, Melbourne and Perth, from which we service not only Australia but also the Asia Pacific region. So that's just a very quick intro. We will, without further ado, I will move on to talk 2 from Marton Marosszeky, who's going to talk on premature deterioration of basement structures. Marton Marosszeky and his talk on creating durable basements. Take it away, Marton. Thanks.
Thanks, Jono. Hi, everyone. The reason why I thought I'd put together a talk on basements is that this is probably one of the parts of buildings that causes the most problems. And so we see problems in newly built structures. We also see problems in older structures that were still well within their service life. I'm going to talk about 3 particular things. One is determining what is the right exposure category. And then I'm going to talk about cracking and controlling water. These are 3 of the key challenges in getting this right. We've been in situations where a basement that looks like the one on the bottom right is held out to be a Class A exposure category. So what is it? Is it an A, a B, a C or a U? And clearly in car parks, we have more carbonation than we do in office buildings. A Class A category tends to be what we've got. A1 is the top left, an office. We do have carbonation, but we don't have water. When we go to car parks, of course, we have more carbonation, and generally it's quite difficult to keep water out of them. It can be done, and I'm going to talk about some challenges that are presented and some ways of doing that. And then, of course, in the bottom right-hand corner, I have a car park with a wet boundary. And so as well as carbonation, we've got water, and we can have salts if we're near a large body of water. So let's look at this problem of determining the exposure category. So starting off with this photo. So here we actually do have a basement, which is below the water table, and it's a saline water table. It's not seawater, but it's still a higher salinity water table. And what we see when we look at it, along the edge of the slab, we can see that it's damp. We can see areas of this column which are damp. So we have the water from the boundary soaking into parts of our concrete, and the moisture evaporating and leaving salts behind at the surface. We can see actually that the salt contamination can come in quite some distance, and so the salts are not contained at the edge. They can come in, they can start causing mischief within the structure quite early, and we've seen this as early as 5 or 6 years after a structure is completed, and certainly within 10 years you can get into some serious problems. So certainly if you've got salt water, keeping it out of the structure is a major challenge and a really important thing to achieve. And if you can't, then how you manage the water is a critical thing, and I'm going to talk about that. This is actually the underside of a slab once again, it's a basement which has got a saline water on the outside. And this is the table salt that you have on your lunch, basically. So this, within 10 years here, this is probably at about 8 years, 9 years, we have this sort of salt buildup on the underside of the slab. This is within the return air plenum. So once again, you know, salt, we know from our dining rooms that basically it's hygroscopic, it attracts moisture in summer, and it's deliquescent, it goes into solution. So basically what we have, once we've got salts in solution, they are mobile within the concrete and they start migrating towards the reinforcement. So, you know, a major problem that we often don't see until we get into, say, in this case, the return air plenum. But still, this is a part of the structure that we're trying to protect, design and protect for a service life of at least 50 years. So I've got this sketch that I have developed, and my purpose here is just to show what's going on. And this refers back to some of those photos that I've just shown you. So certainly, you know, water can come through joints and cracks in the boundary wall. And you've got to go to a lot of trouble to avoid those developing. And of course, I'm not talking about how do we keep water out of basements. That's a talk in itself, but keeping it out is not trivial. And we see waterproofing failures, even when attempted, are rarely successful. They can be, but they're often unsuccessful. So we have water seeping through the wall. But look at some of these interesting problems. We have salt-laden air coming in through intake vents. And we have seen salt deposits on the underside of slabs where the intake vent is pointing towards the prevailing winds, and we've got salt-laden aerosols coming in off a large body of water and being drawn into a basement. The challenges that we need to consider is that, let's face it, the architect is not going to be thinking about this. His decision is aesthetic. The air conditioning consultant is not really thinking about this either, because he's just thinking about the design of the internal system, where it's best to get the air from. So we have to bring this to the conversation. Where is the air intake? What way is it pointing? Because there's no question that salt-laden air can, well, first of all, we've seen air conditioning infrastructure just rusted out within 5 years if it's set up the wrong way, but it affects the concrete structure as well. The other thing is this drain here. You see, we saw water coming down around the edge of a slab there in the photo, and we saw a damp edge, and we saw it running down the wall. So as the slab shrinks, it tends to pull away from the wall, and there's a gap created. There can be a hob here. Now, if we have some cracks, then we have moisture which will migrate along cracks. We have moisture that will, well, for a start, let's just go back a step. From a design point of view, the architect is responsible for waterproofing usually. It's in their work package. The engineer is responsible for the wall and slab and the quality of the concrete and the reinforcement to manage cracking. They tend not to talk about this problem because they're two separate disciplines working in their silos busily. And so when you apply the membrane, what sort of membrane, how it's applied, how that ties in with when the cracking occurs in the slab, all of these things are absolutely critical if you have a basement with a wet boundary. And of course, the photo that I showed you showed that water was coming around here. Water was migrating along cracks, and water and salt deposit was on the underside of the slabs. Difficult problems to solve, multidisciplinary questions between us and other disciplines, and often those conversations don't take place until we're having an argument somewhere over an insurance claim or in court as to who should be paying for the remediation. And carbonation, of course, carbonation is accelerated in a car park. We have seen that the rate of carbonation varies from slab to slab depending on the efficient flow of air within the basement. Not our problem, but a problem we need to talk to the car park ventilation consultant, just to emphasise the need to make sure that there are no dead ends within there, because certainly we see carbonation caused deterioration combined with moisture in basement structures, causing significant repair costs within the service life of structures. So, and of course, it's the combination of water with carbonation. We're not in an office. It's very hard to keep water out from the point of view that on rainy days like we have here today near Newcastle, basically cars are bringing water in and out of the car park all day. So we get water ponding on the slabs, and inevitably we do see that there are cracks in our basements. In fact, I think we're paying as little attention to cracks in basement structures as we ever have in my life. So, is it an A, is it a B, is it a U? How well are we managing the crack control? Is there water? There's always some water. Is the ventilation effective? So these are key questions, and these are questions that we have to discuss with the design team, because they're not questions that we can answer unilaterally. In fact, it's got to be a team effort to get this right. And of course, it involves construction as well. So we give advice on determining the exposure category. And one thing we can categorically say, in a car park, it's very rarely A. But we have seen it if there's salts involved, and those salts, the wet boundary has got saline water coming in it, and we see evaporation off our structural members, we're getting into U. It's actually a worse exposure than you get next to the harbour, because what you have is constant evaporation on the inside, a build-up of salts, and we have seen it, for instance, in some tunnel structures where, with fairly low salinities, we get to really worrying levels of chlorides on the inside of a structure. So slab cracking, and Inam talked about aspects of thermally caused cracking, and of course shrinkage comes in as well as that. And I guess in a straight slab, thermal issues are not that significant, but restrained cracking has similar problems to the ones that Inam was touching on with the thermal question. And so managing the cracks, limiting the cracks, is a challenge for the designer and the construction team, because if we don't manage these, then we will have problems quite early in the life of a structure in some environments, and certainly within the service life of most car park structures, whatever the exposure is. So keeping water out is critical, especially salt water, even with low levels of chlorides in that contaminated water. We have to limit the crack widths, and that's a design challenge, but it goes to construction. So we have to work closely with contractors, and it really is up to the design engineer to make the contractor aware that, hey, this is not in Dubbo. We're actually under a saline water table here. This is a critical application, and what we need to do is manage the cracks, because quite often we've seen cases where the concrete is right, the reinforcement is right, but it happens to be a 38-degree day with a westerly blowing, and no one thought about it at the last minute, and they went ahead with the pour. So, it depends on how important it is, but care has to be taken. So controlling the slab cracking is complicated. We see that quite often normal class concretes are 600 to 700 microstrains. We do have lower shrinkage concretes available with special aggregates and special admixtures to bring that down to as low as 300, 350 microstrains. So certainly, that's an option there for designers to think about. A construction issue, do we just pour that slab in one, or do we pour it in segments and allow segments of concrete slab to take up some shrinkage cracking, some shrinkage movement, shrinkage strain before we pour the intermediate parts? So quite a lot of thought and care has to go into managing this, especially in critical environments, because it's hard to get it right. And we need to specify much smaller crack widths if we're going to avoid serious problems in a chloride contaminated environment. It's not good enough to accept even 0.3 millimeters. We have to get it down to 0.15 to 0.2 in our view, if we're going to avoid problems with basement slabs in contaminated environments. To the walls, similar problems. We've got to get the concrete right. We have moisture coming through, so if we do control our cracking, if we do control our joints so that we don't get water coming in through cracks and joints, we still do have moisture coming through the concrete slab, saturated on one side, evaporation on the inside, and as I mentioned before, even with relatively low salinity in the groundwater, this can build up to critical levels on the inside and cause problems within the service life of the structure. Initially, we start to see some surface exfoliation, we basically see the surface paste being blown off by the crystallization of salts just below, and of course those salts then start to migrate back in because we get a high concentration at the surface, and then they start to migrate back in towards the reinforcement. So once again, a concrete mix challenge to bring down the permeability. We can add mixtures to do that, but there's quite a bit of specialist knowledge required to manage both the mix design and the construction aspects of that. And if water comes in and it's designed as a wet basement, then the free water drainage is a critical issue. Just on that free water drainage, you know, most civil engineers working in structural design of basements don't know much about the application of waterproofing membranes. And because of the way we outsource work into different packages, we end up with people just applying a waterproof membrane in a car park edge. And so we haven't thought about at what stage do we apply that relative to the shrinkage of the concrete? What detailing do we have for the waterproofing membrane to accommodate the movements that will take place inevitably? What sort of membrane do we specify? There's large differences between the flexibility of membranes. And so this is a real area that we just can't leave someone to treat it as if this is a bathroom somewhere. Even there, of course, we get bathrooms in buildings wrong a lot, but you know, this is a really expensive problem to solve. So we need to work with the design team to get it right. So I've gone through the main challenges that I see, and you know, I guess the two main themes that come out of this presentation, one is that we need to work with other designers to manage these specific risks well. We've got to get the exposure category right. I mean, believe it or not, I was given some information in the last couple of years that shows quite a number of basements well below the saline groundwater are designed as category A structures. And if any water comes in, that certainly isn't going to be right. Designing for crack control, we actually see generally in basement structures, we see cracking is not thought about carefully. We've seen cracks in basements that you can pass your correspondence through. You can read a letter on the other side of the slab if you lie down. You know, so we're seeing a lot of cracking in basements. So it's clearly not front of mind. It's just seen as a utility area. Let's just bang the concrete in and get the building going. We're in such a hurry. This is one of the most critical parts of the building to think about. That communication between the durability engineer and the constructor to make sure that the design is actually achieved, and keeping the water under control if it's going to be allowed in at all, and then managing the ventilation, things that we often, well, we see them not being thought about at all. So to conclude, I guess as durability consultants, BCRC cover the range of issues that I've talked about. Certainly getting the right exposure category is critical, and look, it's not something that everyone agrees on. There's quite a few different views, and it depends on the experience of the designers. But we certainly have an informed view on this because of the work that we do in basements. Getting the concrete mixes right, both in the slab and in the wall, and making sure that the construction team delivers that work to the standard and control that is required. Thinking about the design of reinforcement, we're surprised at sometimes the lack of attention given to the control of cracking in terms of reinforcement detailing and quantity, and managing the water and the air that comes into the basements. So I guess I've just tried to highlight the areas that we see often going wrong. These are risk areas in terms of the performance of a building. They're expensive to fix up, and they're areas that we're able to and happy to help with. Thank you very much.
Thanks, Martin. Yes, good last slide there. We've got a couple of questions, and if anyone wishes to ask a question, put it up now so that we make sure we get to it. So the first question for you, Martin, is great presentation. Have you seen examples of less carbonation in structures where carbon monoxide monitors and air plenum/ventilation is well designed?
It's not something that we've studied, but we have in going into some basements where there are some problems and where we've had to investigate causes of corrosion and looked at carbonation rates in different slabs. We've seen quite a difference between areas of the car park that are well ventilated and areas of a car park that are much less well ventilated, and there are significant differences. So it's an important design challenge for the ventilation designers, and we have to voice our concern as durability engineers and structural engineers that it's really important that that's done well.
Okay. There's another question. You did mention a few times, and towards the end there you emphasised it as well about the exposure classification and how important that is. So this question is around that topic. It says, do you think Australian standards, for example AS 3600, adequately define and allow engineers to select the appropriate exposure classification for a basement car park, especially where there is risk of saltwater ingress?
Well, the simple answer is no, and that's why we have the Z series of documents that have been published over the last, I guess, 5 or 6 years, and Frank Papworth, one of our partners, was chairman of that process, and we've got a much more differentiated set of information in, I think it's Z706. I'm not sure of that particular number, but one of the Z series documents that deals with this question, and that's reflecting a wider range of categories that are considered in Europe, and we've drawn on that. The authors of that document have drawn on that. The reason why the Z series documents are so important for everyone to be familiar with is that, in fact, some of our standards, well, firstly, there are inconsistencies between different standards, which we hope will get sorted out in the fairly short-term future with the development of the Z series documents, because they are attempting to bring us up to date with international best practice. So we need to see more consistency between standards, and certainly, yes, AS 3600 doesn't give sufficient guidance. But of course, you know, it has got category U there, which says, look, this is an area that is beyond the standard. So go and talk to some people who know what they're talking about and come up with design requirements that are appropriate to the need. And certainly if you're below a saline water table, I think it's critical that you do talk to durability engineers, talk about what that classification should be, because I believe if you've got a wet boundary in a basement below a saline water table, then you're definitely in exposure category U, and you need to be looking very carefully at the detailing and the design of the structure.
Yes, very good, very good. So another question, Martin, is from someone that says, thanks for this. I believe this would be an even bigger problem in underground box structures in industrial and infrastructure projects. Your thoughts, please.
Well, absolutely. I guess you don't have the accelerated carbonation in those structures, I assume, but certainly we have seen in underground, in tunnel structures, in culvert structures. Certainly those are two that I can remember us dealing with in the recent past. Exactly these problems occur. So if you're in a contaminated groundwater situation, then any concrete structure that is below the water table is going to have these sorts of problems, and you have to really look carefully at the design and at the execution. I think it's important to note that if you're using precast elements, then they can be manufactured to a higher standard, and the jointing is the critical issue there, but the concrete itself can be produced to a higher standard with greater care taken in terms of producing the elements that might go into a structure that's below the water table.
Okay, and the final question here is, thank you for the presentation. Can you elaborate on the timing of applying a waterproof membrane?
I was contemplating that question as I put together the presentation, and I suspect it's something that is not actually considered as late as possible. So oftentimes a basement is built and a substantial building goes on top of it. And so maybe you put in some initial waterproofing, but certainly the final waterproofing, I think, should be one of the things that go in when the building is almost ready for occupancy. Because, you know, if you're putting one in early to try to control water flows and nuisance during construction, that there's a fairly good chance that will get ruptured as shrinkage takes place in the places that I described. So I think that I would definitely advocate a very carefully applied waterproof membrane just before occupancy. By then, shrinkage has taken place, and the chances of the waterproofing membrane actually surviving and performing its function is maximised.
Great. Okay, I think that's it for questions, Martin. So thank you very much for your presentation. I hope everyone enjoyed that. So that's essentially it from us today. We'll wrap up there, and it looks like we've snuck in under the hour mark. So that's fantastic news for everyone, I'm sure. We all do appreciate very much you taking the time to attend today, given it's the busy lead up to Christmas period. And I hope you all did enjoy that. We will be doing another one next year, and we hope to make this a regular occurrence. So please do stay tuned for the next in our series of durability webinars. You can sign up for our e-newsletter. You can sign up for that on our website, or you can follow up BCRC on LinkedIn or via a few of our other social media channels to keep up to date with what we're doing and projects we're working on, etc. And look, this was our first webinar, so if you do have any feedback for us on ways we might be able to perhaps further improve the experience for everyone going forward, then we'd absolutely love to hear that from you. So please get in touch. That's it from us. So thank you very much, and we'll see you next time. Bye.